this video, we are going to discuss about one problem based on Elmore delay. Okay, the question is realize the n input NAND gate with parasitic delay and find Elmore delay. So, if it is a NAND gate means you have to connect the two NMOS in you have to connect the NMOS in series. Okay, so let me assume so this is how the NMOS should be connected. Okay, and PMOS should be connected in parallel. So in the problem they have given, we are using n NMOS. So what is this is 1 means this becomes n. Okay. So this is your VDD and this is your Vout and this is your ground. So you can replace this transistor by resistor and capacitance. Okay, so since the value of PMOS is 2, okay, and if I connected n PMOS in parallel means each of the transistors having the value as 2 ID. Okay. Okay. Next, here if I have only the NMOS value is 1. Okay. So if I connect 2 NMOS means the NMOS value becomes 2. This is also 2, this is also 2. If I connect 3 NMOS means this is 3. Okay, so if I connect the n NMOS means so this value is n. Okay. So I can write the capacitance value of this NMOS is NC. Okay, and for this value it is 2 NC, right? Why it is 2 NC means if I connect only one PMOS means it is 2C. Okay, so if I connected 2 N types of PMOS means it is 2 NC. Okay, so therefore I can write if I add these two, since these two capacitance are connected in parallel, so if, this 2 values becomes NC plus 2 NC, that is equal to 3 NC. Okay. So for this one it is NC. Okay, this is NC, and for this one also it is NC. Okay. So now let us take, let me read out this diagram. I am going to consider only this part. Okay. From my ground to output. So, okay. So this is my R by NC. N r by n. Okay, so since this value is n, so I have to write it as r by n, and I have to start from ground to resistor followed by this capacitor. Okay, so this value is nc. After that I have r by another transistor, okay, that is also nc. Okay, so another transistor r by n and nc. Okay, so it goes on right till r by n. For this value, this is r by n. Output is 3 nc. Okay, so this is my V out. So for this one, you have to find the Elmore delay. Okay, so in order to find the Elmore delay, you have to take this capacitance. Okay, so this capacitance value is nc. Okay, so what nc means, what is the resistance before this one? It is r by n. So for this nc, resistance value is r by n, that is this one, plus r by n. Okay, so for this one it is nc into r by n plus r by n plus r by n. Okay, so and it will go on. Then I can write r by n plus for this one. Okay, r by n plus r by n into 3 nc. So I can write this one as nc r by n plus 2r by n into nc plus 3r by n into nc plus, suppose this value is n means, okay, if this value is n means, previously this value becomes this is up to this one it is n minus 1. Okay, for this one it is n minus 1. Okay, so therefore I can write this as n minus 1 r by n into nc. Okay, plus top. So for this one it is n into r by n, okay, into 3 nc. Okay, so if I solve, if I take r by c for this one, okay, for this one, if I take RC common, I will get 1 plus 2 plus up to, it goes to n minus 1. Okay, plus RC three L. Okay, so this I can write it as, if so we know that 1 plus 2 plus up to n is, so formula is n into n plus 1 divided by 2. So here the formula is like this, n plus 2 plus n minus 1. So what is the formula? It becomes n minus 1 into n minus 1 plus 1 divided by 2. So the formula becomes n into n minus 1 divided by 2. So you substitute this one. RC into n minus 1 divided by 2 plus 3 RCm. So this becomes, if I take RC common, n square minus n divided by 2 plus 3n. So this is equal to RC n square minus n plus 6n divided by 2. So this is equal to RC into 5n plus n square divided by 2. So this is my formula. So suppose if they are asking for find Elmore delay for 2 input NAND gate. The question is like this. So I have to substitute n is equal to 2. So if I substitute n is equal to 2, I will get RC 10 plus 4 divided by 2. That is equal to 14 divided by 2 is 7 RC. So this is my Elmore delay value. So next let us discuss about logical effort and parasitic delay for Tristate circuits. So the Tristate circuits, it has an input A and output Y, and you have an enable pin. So if the enable pin is 1 means the input will reach the output. So if the enable pin is 0 means you will not get any output. That is Y is equal to Z. This Z represent high impedance state. Okay. So this Z represent high impedance state. That is floating state. So I can draw. So this is my area. Okay, and this is my E. So this is my Y. Okay, so if we see my Y is my E is 1. Okay, if E is 1 means whatever the value, if I give A as 1, okay, A as 1, so this is A buzzer. A as 1 means this will be activated, so I will get the output as 0. Okay, so if this is if A is 0, if A is 0 and E also 0, okay, and then it should be E bar. Okay, E bar is 0. If E bar is 0 means E is 1. If E is 1, VDD will reach the output. Okay, so this is my Tristate circuit. So for this one I need to size, and I need to find the value of logical effort and parasitic delay. So if I size this one as 1, NMOS, if I take this as 1, so 2 NMOS is in series, so the value is 2. Okay, so we know the value of PMOS as 2. So since 2 PMOSs are in series, so this will be 4. Okay, So if I want to find the output capacitance, the output is connected to E bar and E, and then that value is 4 and 2. So addition of this two values 6. So input capacitance means input capacitance is connected to 4 and 2. So addition of this value is C. Okay. So what is my parasitic delay? Parasitic delay. Parasitic delay is C out divided by C in of the inverter. C in of the inverter is, we know there is 3. C out of this value is 6. Okay. So answer is 2. Okay. So if I want to find the logical effort, is C in of the gate, that is 6. Okay. Divide by C in of the inverter. C in of the inverter is 3. Okay. So the answer is 2. So suppose if I want to find it for 2:1 mass. So we know that the equation is y is equal to S bar A plus S into B. This is my 2:1 mass equation. So for this one, how to draw the diagram? So this is my A. Okay, this is my A. And I need to connect S bar here. Okay, so what is the answer here? This is nothing but S bar into A. Okay, this is my S bar into A, and similar way I need to connect B. Okay. So B into S. So this is my S and this is my S bar. Okay. So this is my B. Okay, I need to add these two values, right? And I'll get only the whole bar values, right? So if I want to plot this one, okay, that is y bar is equal to S bar A plus SB. Okay, so I need to add this one. So if I want to add, I need to connect this output with this out. So these two are in parallel now. So what is this value? This is nothing but S bar A plus SB, the whole bar. So if I want to size this one, this is nothing but 2, 2. Okay, and this one is 4, 4. So what is my output capacitance? The output capacitance value is, so it is connected to 4 transistors. So this is 8, 10, 12. So this is 12 C. And what is this one? This is 4 plus 2 is 6C. Yeah. And this one is also 6C. Suppose if I want to find the logical effort of S, okay, it is nothing but output capacitance divided by input capacitance of the inverter. That is nothing but 4. Okay. So if I want to find the logical effort for A is 6C, right? So if you see the logical effort of S, 4 plus 2 is 6, 6 and 6 in get turns. So you have to see the input of the A. It is 6C, right? So 6C divided by 3C. It is 2. Similar way, if I want to find for B, it is 6C divided by 3C, that is 2. Okay. So if I want to find the parasitic delay, it is P, it is 12C divided by 3C. Okay, 12C divided by output capacitance by the input capacitance of the inverter, it is 4.